Hello and welcome to this Common Lisp video. This is the one about macros. So if you've been wondering why I've been talking about Lisp for these past few videos and why it makes a better language than any other language that you might be familiar with, this is it. This is the video on why you should be paying attention and why it's worth your time to learn Lisp. Macros. Now, if you come from the C world where you can hash include and hash if def and all that, they are compiler macros. They're macros to your C compiler, not to your C language, and it's an important distinction. And it may not necessarily seem quite the same. So we're going to drill into it. We're going to get into macros here. So let's jump in. So a macro is somewhat of a code substitution, basically, and it's both why Common Lisp has weird syntax and why it can't really have any other kind of syntax, to be honest. It looks weird, but it gives you great power. So let's have a look. Everything in Lisp is a list. It's kind of in the name. It's a list processing language. So this is a list. It's a list of the plus function and the operand 1 and 2. And we can turn that into a list by quoting it. What? Mech doesn't... No, I'm not trying to. Go away. Not sure why that's doing that. And there we go. So we get a quoted list here, which if we click it, is it going to let me... here we go, yep. It's a series of consoles, it's a proper list. List element 0 is the plus. Let's increase the size there. Is the plus function, and these are the two operators. If I click that, it'll tell us that it's the global symbol plus. It's a function. So we've got all this stuff here. So let's jump back. Let's see if we can do something else here. Just gonna quickly test this. Just gonna make sure that this is working. Yes, it is. So, right, not sure why that wasn't just letting me quote it in the editor, but we saw in the REPL here that we can quote a list, and if we take the quote away, it evaluates to a value. So, and here's where the technical terms come in. Lisp is a homoiconic language. Its code is expressed in terms of its principal data structure, which are lists. And so lists and code can be passed around. So code is data, and that's why the syntax is all weird with the parentheses. It's because everything is a list at the end of the day. And when you get a list, that is being evaluated, the first element in that list is presumed to be a function. Now, what we've got here with this little quote mark here, this is actually just some syntactic sugar for this. No, it's not that. What am I doing wrong? Yeah, there we go. That's what I meant to do. So, quote of that. This is the long form version of this. This is just a little bit of syntactic sugar because we are quoting a list. You can just as easily just put a quote sign at the beginning of a list, and it is identical to this. Ignore my misunderstanding. I thought it was list. I was wrong. That's for something else. So this is all quote is, and so we can quote a form, a function call, and if we quote it, it becomes a list rather than being evaluated. Now, as we've seen in previous videos, if you want to, if we go think back to our tic-tac-toe video, if we want to have a list that is being made up of the evaluation of some things, for instance, if we do this, we'll use a shortcut form. So we're going to say the plus or let x be 1 and y be 2. We can see here that although we're quoting it, we're getting the symbols x and y, not the value that those symbols point to. So what we would actually want to do is use the backtick and the comma, and that gives us a list with those values. So if we're quoting something and we want values, we just have to use this syntax here, and that's exactly what we're going to do now. So to get the simple description out of the way, a macro is a piece of code that can receive parameters, of which those parameters might themselves be forms and blocks of code, and it returns some code in the form of a list. And if that sounds a bit mental, it is, but that's kind of why we're here. I'm going to build you a small example, because I built I built a library over the last week, a very trivial library to help me actually learn myself, but also to solve some of the problems with the tic-tac-toe game we had. So I'm going to build a very simple macro that it takes a number of arguments, and they're just going to be literal values, and then it will return some code, or it will return a list that represents some code that will do something with those values. So to define a macro, we'd say def macro, and typically with macros they have with. So I'm going to call this with multiple EQ. With multiple equal is what I wanted. No, we're going to have multiple EQL, and we're gonna write the rest as we go, because there's going to be 4 of them, and they're all going to be pretty similar anyway. So this is going to take some REST keywords. This is, if we haven't seen this before, REST is very similar to our key arguments, except it gets a list, and we're going to say this. So we've got our high function that we just compiled. High A B C. So we pass in 3 parameters, and we get this output here just with our format thing. So all of these, although there's no named parameters, all of these are flung into this args list, and then we can unpack it. So that's what REST is. It's just if you don't have a named parameter, anything else will just get dumped in here. It's similar to Python's *args, if you're familiar with that, or the JavaScript spread operator for function arguments. That's all it is. It's just REST parameters. It looks a little bit different here, but other languages do have it. So just going to unbind that and get rid of that function. So that's what we're talking about here. We've got a macro that's going to take an n number of arguments. This macro is going to be what they call n-arity. It's not defined as having 1 or 2 parameters. It's defined as having n, as many as you want to give it. And all it is, it's going to return one of these special backtick lists, where and is the first parameter, And where we've seen previously, we have this comma for a value. Now if that value happens to be a list that we want to unpack, we use this @ sign here. And we're going to use mapcar. Mapcar is a function that takes a function, so we're going to pass it a lambda, which takes an x. Then this is going to return a backticked list as well. So this is going to be a backtick list of EQL, which is the function. Then we want to comma quote it with first args and comma x. Then we want to give it rest args. And that is it. This might look very, very strange. So we'll start picking this apart. I'm just going to do a format. Just this list unpacking thing again. So we can see mapcar. So there we go. This is all mapcar does. It's a simple map function. We pass it the list of 1, 2, and 3, and then it gets this lambda function which takes an x and multiplies an x by 2. So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So we got our 2, 4, and our 6 here, and we just print it out. And that's what mapcar does. So we can see what this bit of it's all is doing. At least this bit. We've had a look at what rest does. If we haven't, we've got first gives us the first element in a list, so there should be 1, which we can see down here. It gave us 1. And rest gives us everything except the first argument, so this should give us a list of 2 and 3. Now, I prefer these terms, but traditionally this is what they'll be called. So this gives us the 1, this gives us the 2 and the 3. So this is the contents of the address register and the contents of the decrement register, and these are throwbacks to the original machine architecture upon which Lisp was first developed. It doesn't really have a lot of meaning in the 21st century. However, they are fundamentally the first and the rest of the list, or the head and the tail, whatever your nomenclature is. Most code will probably use car and cadder, and that's fine. But for clarity, while we're talking about this, I think first and rest is clearer as to what it means, and the Common Lisp standard does say that these point to car and cadder, so they are the same functions. So we get this this thing here, and we're going to say we want the equal function to be the first element in a list, or the symbol that represents the equal function to be the first element in this list. Then we want to get the first argument, so this would be, in this case, this would be 1, and the x, so we will get an x at some point, and the list that we pass into the lambda function is the rest of args. So the first element is always the second element in this list here, the first element being equal, so it'll be equal 1, 2, equal 1, 3, based on this example here. So that's all that's doing. So we can see let's create a little let block. This is 1, 2, 3. I'm just going to say mapcar lambda of x, which returns equal first L. rest L. There we go. So this is what we've got here. Map car returns a list. We've got two elements because we're taking the rest of L. We're ignoring the first element here. So it's a list of 2 and 3. So we get equal 1 of 2 and equal 1 of 3, which is exactly what we want. So getting rid of that. This is what happens here. Just this whole thing here gives us that list. And that list then is actually unpacked and put in another list, so we can actually see that this list returned by the macro, not the map car. The macro is going to be a backtick list of and then whatever this returns put in place. So what we will actually end up with is, let's bring that let back. There we go. So we get, we will have and in this list here right at the beginning. So we can backtick this and see what's going to happen. Oops. So we get something wrong here. This isn't what we want. So we get the map car list in place here because it's a literal, and ordinarily we'd have to comma quote it. But this still won't give us what we want because we actually have this as a list in here. So we've got and of a list with these two things inside it. So what we want to do is break that list apart and actually just have and equal 1 of 2 and equal 1 of 3. So we've really looked at what we've got here. We've just used this let block to emulate what we're doing here. So let's get rid of that. And we're just going to compile our macro here. We've got it. Now what we can see is we can do with multiple EQL. So this could be, we want these three things to be checked to see if they're the same, and they are. We got T down here. So let's change that to something else, the different symbol, and we'll get nil. So it has figured out that these three things are not the same, and this was the problem we had in our tic-tac-toe game. Is we needed to check if more than two things were the same, and the EQ, the equal, and the equals function, they couldn't do it. They took two parameters and that was it, and we had to write a long chain of ands and equals to emulate it. So I wanted to write a macro that could be called like this. So we pass it this with three things and it will figure it out. Now, this is not the crazy thing, because if you didn't see def macro here, you might just assume that this was a function. And indeed, it probably could be. But let's have a look at this. So macro expand one will take a list, and it will apply that list to the macro, and it will show us what this actually is. So we can see here. Let's format this. Let's make it easier to read. So we've got it here. We can see what we've got here, and although this is how we type our code, and this is how we want to work with it, what it actually translates to under the hood is this, which is the code that we were having to write otherwise. But instead of writing it out explicitly like that, we can write a very simple, as it turns out, a one-line macro that will take our name and our values, and it will generate the code for us at runtime and do a substitution of our function call here. And the compiler will replace this function call with the result of calling the macro with the arguments, with it generating the code, much like it would resolve a variable. So where we get our lets with our backticks and our comma quoted variables, where it substitutes and knows that, well, this x represents a value, so let's plug that value in here. Because lists themselves are values, and because we're talking about code being represented as lists, which is a value, it's basically just doing a variable substitution here, doing a quick calculation and replacing our macro call with the result of this macro. And it's really, really clever. And because of this, it can enable all sorts of stuff. And as it turns out, the rest of the library that I've been working on this week is basically trivial. So we can copy this, and all we do is EQ, EQ, do something here, export colon comma, no, hash colon with multiple EQ, hash with multiple EQL, hash comma with multiple equal, hash colon with multiple EQL equal P. That's it, that's my library. It really wasn't a lot of code at all, and we'll do some quick examples here. Let's compile them all. So this should fail because these should be 3 distinct strings, and EQ refers to object identity. So this should be nil, which it is, which is great. However, symbols should be the same. They should be identical. So the symbol X, the symbol X, and the symbol X. This is true because these symbols are they share address and memory. It points to the same object. So what we can do, you know, this is true because they're all symbols and, you know, whatever. So equal, which will work on comparing the equality of strings, this is true. However, if we put a capital X here, this is nil. But equal P will compare strings irrespective of their casing, and we'll get T, although it would help if I put a different string in. There we go, a capital X. It's still true because the semantics of equal P says it will ignore case and just try and like smash the strings together and go, is this basically the same character or the same sequence of data irrespective of casing or anything like that. So we now have these 4 macros that are one line, and the only thing that differs is the function that they call, and if I could find a way to reduce it down even further, I will. But given that they are one line, I can't see adding some sort of abstract way in to figure that out with a different name. It's probably more hassle than it's worth, considering that this does exactly what I want it to do. Now there's something else to have a quick look at. So there's a macro expand as well, rather than a macro expand 1. And it basically does it translates it slightly differently. I don't know why. Let's see it with different things. Okay, so there are different things. I'm not sure why it expands like that. I'm not quite there on the difference between the two, but macro expand and macro expand 1 do different things. So where we've got this if that, then it runs that. We get the and there. Maybe that's something for the next macro video, is understanding the difference between the macro expansion functions, and you know when to use them where. But yeah, here we are. This is macros in Common Lisp. Why Lisp as a language in general, and certainly Common Lisp in particular, is definitely worth your time. If the language has some things in it that you find you need to work around, or there is something that you wish that it did, and you want to basically implement that, macros are how you do it. And again, with the tic-tac-toe video where I was limited in my ability to express a solution to a problem because the language didn't have equality functions that would allow for more than 2 values, the solution is write a macro and it will generate the code that will resolve the problem for you. And that is pretty damn cool, I think. So we will take this and we're going to plug it in and do a quick video a little bit later on the tic-tac-toe game and how to improve it even further using these macros, and we'll take it from there. So have a great week, have a great weekend in fact, and I will see you in the next one.